Okay, so let's now talk about the addition of matrices. How do we add matrices? So pay much attention. We add corresponding elements. Okay, so addition of matrices is done by adding what? Adding corresponding elements. I'm sure you all know what the word corresponding means. If not, don't worry, you will know. Okay, then addition is commutative. Okay, so what do we mean by commutative? Okay, so this means that when we had matrix B, matrix A plus matrix B, the answer we can get is equal to when we start with matrix B plus matrix A, we can get the same answers. When we start with matrix A, then we had matrix B, the answer we're going to get is the same as when we start with matrix B plus matrix A. That's what it means when we say addition is commutative. Okay, so let me give you an example. So example, let A is equal to 1, 2, negative 3, 3, and B is equal to 2, 0, 1, 7. Okay, then they tell you to add A plus B. Add matrix A and B. Yeah, so here what we do, you say A plus B is equal to, so this is our A, write it like this, plus write matrix B here, 2, 0, 1, 7. Then we said we add corresponding elements. What does that mean? That means that we're going to do this. This is corresponding to this one. This is corresponding with this one. Okay, so you say 1 plus 2, 1 plus 2, then negative 3 plus 1, 2 plus 0, 3 plus 7. As simple as that. Okay, then 1 plus 2, we're going to get 3, then here we're going to get 2, here we're going to get negative 2, here we're going to get 10. So that's the answer. It's very simple. Okay, let's go to subtraction, the opposite of addition. Okay, so how about subtraction? Subtraction, we also subtract the corresponding elements, but it's different from addition, because addition we said is commutative, then subtraction is not commutative. So you have to be very, very careful here. Remember we said matrix A plus matrix B gives the same answer as matrix B plus matrix A, but this does not apply to subtraction. Okay, so here we are saying we add corresponding elements but it's not commutative. It's not commutative. Why? Because A minus B is not equal to B minus A. Okay, so subtraction is not commutative. Let me give you just a simple example. For example, 2 minus 1 is equal to 1, but 1 minus 2, the answer is negative 1. This is the reason why we are saying subtraction is not commutative. But when we go to addition, 2 plus 1, the answer is 3, but 1 and 1 plus 2, the answer is still 3. So addition is commutative because it gives the same answers. Whether you swap or not, you're going to get the same answer. Okay, let's look at the example. It's an example. They tell you to subtract A from B. So A minus B is equal to, remember we had I made the mistake here. We subtract so we subtract the corresponding elements. Okay, so the same way we are doing the time we are adding, we subtract the corresponding elements. So where we were adding, here we are subtracting. So 1 minus 2, 2 minus 0, negative 3 minus 1, 3 minus 0, 3 minus 7, then in 1 minus 2 is equal to negative 1. Then 2 minus 0, we're going to remain with 2. Negative 3 minus 1 is negative 4. Then 3 minus 7, we are going to get negative 4. So this is our final answer. As simple as that. Yeah, so let's go to the next property, and this is multiplication of matrices. How do we multiply matrices? So we multiply them row by column. We multiply row by column. So this one usually comes because there is a trick, but we are going to figure that one out so that even if it comes this year, you will answer it without in fact there is there is nothing like a trick here. It's very simple. Okay, so let A is equal to 1, 2, -3, 3. Then B is equal to 2017. Then they tell you to multiply A times B. So what we're going to do is, okay, we multiply row by column, but listen very careful. Yeah, so you need to pay much attention. You listen very carefully here. Okay, so row by column. So when you start with this column, you multiply, when you start with this row, you're going to multiply by this column. Okay, let's do that first. So you open the bracket, then you say 1 times 2. You close, then you say -3 times 0. Okay, again this same row by this second column. Okay, so again you leave the space, then you say 1 times 1 plus -3 times this 7 here. Hope you are getting me. Again, we start with this row. We are done with this row, then we're going to start with this one. So again, this is the row. So we're going to start with this one again. So we're going to say 2 times 2 plus 3 times 0. Okay, we are done with this column. We're going to start with this one. You leave this small space here. You say 3 times 1. 2 times 1 plus 3 times 7. Yeah, this is the only trick part. So now just start multiplying. You say 1 times 1 is 2. 1 times 2 is 2. 2 times 2 is 4. Plus 3 times 0 it's 0. 3 times 0 it's 0. 1 times 1 is 1. Plus -3 times 7 is -21. 2 times 1 it's 2, plus 3 times 7 it's 21. This is 2, 4, 20. I mean -20. Here we're going to have 23. So this is how we multiply matrices. Okay, so we go to the next property, and this is scalar multiplication. Yeah, so this one is different from the previous one. Why? Because here we have a scalar in front of a matrix. Okay, yeah, so we multiply each element of the matrix by a scalar. So multiply each element of a matrix by a scalar. A scalar is more like a number. For example, let matrix A is equal to 1, 2, -3. Here you have 3. Then they tell you to multiply. They give you a scalar 2. They tell you to solve this, meaning this is a scalar. So you multiply everything in A by this scalar. So you are going to have, so 2A is equal to 2, then A is 1, 2, -3, 3 here. Okay, so is equal to 2 times this. Remember, multiply each element by a scalar. So 2 times 1 is 2. 2 times 2 is 4. 2 times -3 is -6. 2 times 3 is 6. That's all. So this is all about scalar multiplication. Just multiply the scalar you've been given by the matrix. Nothing is very difficult here. Everything is simple. Okay, so the other property of matrices is this one, a transpose of a matrix. Yeah, so what's this one? So this is whereby this is a matrix in which the rows of the original matrix have been reversed to columns and the rows to columns. It sounds complicated. Okay, so you just swap. We are saying the rows of the original matrix, the rows of have been reversed to columns and the rows to columns. The rows have been reversed to columns and the columns to rows. Yeah, you just swap. The columns becomes rows and rows becomes columns. That's a key point here. So how do we do it? Okay, let's say for example we have matrix A. Matrix A is equal to 1, -3, 2, 3. Then they tell you to find the transpose of A. So the transpose of A is written like this: A with a T on top. Whenever you're writing the answers, when they ask you to find the transpose, write the matrix and the T on top of that matrix. Okay, then you swap. Okay, so we have these rows, so these are going to become our columns. Okay, so we have 1A, 1 and -3A. Then we have 2A and this is our 3. This is the transpose of A. Let's say this is our C. We have 1, 5, 7. So when they ask you to find the transpose of matrix C, just like the C and the T on top, then you say these are rows of matrix C, so we are going to make them columns. So we're going to do this: 1, 5, 7. That's all. So this is all about the transpose. Okay, the other property of matrices is determinant of matrix. So at your level, you only deal with 2 by 2 matrix, but when you go to university, you'll be handling questions involving 3 by 3 matrices, but at your level, it's just 2 by 2 matrix. Okay, so how do we find the determinant? The first thing you have to know is that the matrix has got diagonals, 2 diagonals. It has got a major diagonal and the minor diagonal. Okay, what are we saying? So let A be equal to let's say for example we have A, B, C and D. So in this case, which one is our major diagonal and which one is our minor diagonal? Okay, so diagonal lines looks like this. This is how we write diagonal lines. So between these two, there is a major and the minor diagonal. So the major diagonal starts from top left. Then the minor starts from top right. This is the minor diagonal. And this is our major diagonal. So how do we find the determinant? So first thing first, you multiply the elements in the major diagonal. So you multiply the element in the major diagonal. So diagonal. So in the major diagonal we have A, D. So A times D, we are going to have a D. The next thing, multiply the elements in the minor diagonal. In the minor diagonal we have BC. So you multiply B times C, you are going to have BC. Then finally, determinant is equal to, so determinant is equal to it's in short form, determinant of A is equal to products of products in major diagonal minus products of minor diagonal. The answer we're going to get is what we call the determinant. Okay, as simple as that. So before we move on, the other thing you have to know is that when you get the determinant of 0, meaning that matrix is a singular matrix. So the singular matrix is the matrix with the determinant of 0. That's a singular matrix. In case you face something like this. Okay. So this is all about finding the determinant. What's next? So the other thing, one of the most important things about matrix is to know how to find the inverse of a 2 by 2 matrix. Okay, so how do we find the inverse of a 2 by 2 matrix? Again, let A be equal to 2, 1, then 0, 1, like that. Then you're asked to find the inverse of this matrix. So the first thing is to find the determinant. Remember, We talked about the major and the minor diagonal. Yeah, then you subtract the products. The answer you're going to get is the determinant. So first thing first, you find the determinant. Find the determinant. How do we find the determinant? So determinant of A is equal to, this is our major diagonal, so the product of major diagonal minus the products of minor diagonal. So this by this, it's 2 minus this by this, 0. So in this case, our determinant is 2. Okay. Then what's next? What's next is to find the hard joint. What's the hard joint? How do we find the hard joint? The hard joint, we interchange the elements in the major diagonal. What do we mean by interchanging? In the major diagonal, so this is our major diagonal. So interchange means this one will take the place of this one and this one will take the place of this one. So here we're going to have 1, then here we're going to have 2. Okay, then change the signs of the elements in the minor diagonal to get the new matrix B. Okay, so we are going to change the signs. If you have positive here, meaning in the hard joint you are going to have negative. 0 is neutral, it has no charge, so it's going to remain like this. Okay, then what's next is to multiply. You multiply 1 over determinant by hard joint. Let's replace. So the inverse is denoted by the, for example, inverse of A is going to have a negative on top, then is equal to 1 over, what's our determinant? Our determinant is 2. What's our adjoint? Our adjoint is this one. We're just replacing like that. Then if you want to end from here, or if you want, you can continue multiplying. Okay, if we continue multiplying, we are going to get, multiply this one by this one. This is going to be more like our scalar. This is more like our scalar, so we're going to multiply this by each element in this adjoint. So this by this, it's 1 over 2. This by this, it's negative 1 over 2. This by this, it's 0. This by this, it's 1. So this is our final answer if we were to complete it. This is how we find the inverse. The first thing, you find the determinant. The second thing, you find the adjoint by interchanging the elements in the major diagonal and changing the signs in the minor diagonal. Okay, the third step is to multiply 1 over determinant times the hard joint and replace. If you want, you can end from here, or if you want, you can just finish it. It's very simple. I think for today we are going to end from here. I think we have talked about a lot of things. Yeah, so we've just remained with one part, solving simultaneous equation in two variables using I should is it single matrix method? Yeah, something like that. Yeah, so thank you for watching. Have a good day. See you in the next lesson.